3, 2, 1. So is not this beautiful or what? Actually, this is a nebula in the constellation Orion. If you're familiar with Orion, Orion has kind of three stars that make up his belt, and then he has a sword hanging from that. And this is, you can see, not this well, but with binoculars, actually, you can see this nebula. We talked about the term nebula before, and nebula is basically if you're in outer space, and most of outer space there's nothing, quite frankly, so be sure to gas out before you leave. But in outer space, if you run into some atoms or molecules, if you run into a package of atoms and molecules, that is a nebula. And some nebula glow with energy, okay, and some nebula don't. They're dark nebula. So you can have either one. But we're going to look at this later, in a later part in this chapter. And actually in Orion's nebula here, there are stars being born, okay? So going back to what this chapter is about, it's all about us, right? We're going to describe how our solar system came to be from a nebula, okay? It's awesome. And it's called the nebular theory, the formation of our solar system. So our universe is all about conservation. You must conserve, you know, it's kind of a natural thing to do. We should all conserve. We talked in an earlier chapter in Unit 1 about conservation of energy, conservation of momentum. Okay, well, matter is conserved right now. I know that a little bit of matter is being converted to energy in the cores of stars, but aside from that, okay, we recycle. And instead of actually calling this galactic recycling, I'm going to talk you through, it's more like stellar recycling, okay? So let me show you how this works. The top image here, i.e. stellar recycling. Okay, so up here, actually, this is a star on its way to being born. So this is still in the womb. I don't know if that works for you, still in the womb. It's not really still in the womb, but this is a star that's getting ready to turn on. We'll talk about we'll talk more about stars in general, what they do to get ready to turn on. But this is actually just simply hot. It is doesn't have nuclear fusion going on in its core. Okay, you can kind of see the jets of energy. Okay, here, eventually, our star turned on, okay? And so we see that could be our sun kind of ticking through its actually fuel in its core. What our sun is doing is taking hydrogen and combining it with more hydrogen to form helium right now. So here we have an alive star, okay? It is out of the womb, okay? It may or may not have planets. Ours has planets, okay? But part of the recycling comes in with this last bit, okay, on to stage 3. And stage 3 over here is death. We've got, everybody loves the whole death part of stars. Maybe, maybe not. But depending upon the mass of the star, it might blow up if it's more massive than, I think, 8 times the mass of our sun, and the star will go out with a bang. Okay, our star and stars like our mass and smaller, actually they are going to go out with creating what's called a planetary nebula. So that's pretty. I think I mentioned before, a planetary nebula has nothing to do with planets. Basically, it's a star that's near the end of its life and it's kind of sloughing off some of the material that it enjoyed throughout its life and creating a nebula. But let's take the situation where the star is massive enough, and the early stars really were massive. They were humongous. So the star is massive enough and blows up. So that stuff it creates during the supernova event, actually it's called a supernova remnant. And this remnant can actually be stuff that new stars can be made of. Our sun is a second generation star. We know that because it has what we call heavy elements in it. We'll be talking more about that. So that's the recycle part, and that's how it enters into kind of this nebular theory. So we kind of think of the Solar Nebula, I'm going to call it here in a minute, the thing that ultimately became our sun and the planets, okay, as coming from a star that lived its life and gave it back in this recycle process. So the nuts and bolts of how we sort of game how we are a system, a happy star and its happy planets, okay, started out as a solar nebula. And I don't know if you can kind of see those arrows, but it's got little red arrows here kind of showing contraction, and it's got spin Okay, it's got these blue arrows kind of showing rotation. So we have two things going on. Okay, we have contraction and we also have rotation. So with the contraction, we're getting smaller. We're converting, we talked about this in the previous chapter, we're converting, or maybe 2 chapters ago, we're converting potential energy into probably thermal energy. So we're heating up, and this spin, as our footprint got smaller, we would be rotating faster and faster, just like the ice skater rotated faster and faster. So Solar Nebula, contracting and spinning. And the spinning actually created kind of a flattening sort of situation. So you see us continue to contract, spin faster and faster, conservation of angular momentum, just like ice skaters, right? And flatten out. So this actually is, the sun is not turned on here. It's kind of like we saw the first in the recycle. Okay, this is a star in the womb, basically. But can you kind of see that kind of glowing sort of disk? Okay, that material there that's kind of flung out, but still kind of nice and tight in a way to the star, to our sun, that's actually going to be matter that makes the planets. So pretty cool, pretty cool. So I'm not necessarily going to show you this. It just basically emphasizes again. So not only would it heat up as it contracts, but as it contracts, that spin will go faster, faster, faster. Okay, similar to an ice skater. This one, I'm not necessarily going to show you either. Basically, it just says as the rotation, it got faster and faster and faster and faster, those particles, particle number 18, number 14, number 22, 27, and looks like 5, they would maybe be a little bit random at first, but as it started to kind of tighten in, they would go in the same direction, clearly in the same direction. Let's see if this works. If it doesn't, I'm good with that too. Ah, there you go. So you might need to look closely. Basically, they're kind of showing the Solar Nebula getting tighter and tighter. The first one is like face on, the other one is like edge on. Contracting and spinning. Not bad. Okay, so the sun is not turned on yet. Okay, it's still in an early stages. So one last thing I want to show you in this part is this little animation. So your textbook, I think, does a good job of giving you kind of some basic information about the planets in an appendix in the back. But I just want to, let's see. Oh, I guess I have to hover over it. Okay, so this is the sun, and a few things I want to point out. Can you see the red arrow? Okay, that actually is the sun's axis of rotation. It's tilted a little bit relative to the yellow, the plane of the ecliptic, and it rotates on its axis about once every month. It says 25 days, but about 28 days. So then I go over here to Mercury. Mercury, see its axis of rotation is straight up and down. You can see some interesting things about Mercury. Now, I want to show you Venus because we'll be revisiting this. So that's Mercury, arrows up. That's Venus. Check this out. Okay, it actually has what we call retrograde rotation on its axis. Okay, remember Uranus's axis of rotation is lying in the plane of the ecliptic? Well, we think it got whacked early on in its history. So related to that, when we go back to Venus, we think that Venus got whacked even more. So basically, if you look at it from its north pole down, it is rotating clockwise. Okay, so Earth, Mars, Jupiter, Saturn, Uranus,